I'm happy to have on the show today Jeff Draper. He's the founder of Storelectric. They're a green energy technology company powering the transition to a greener future. We were just talking about how you got into the energy game.
I started out as a physicist when I went to university. I did maths and physics at Manchester University. And then I came out of that. I didn't know what I wanted to do. And I qualified as a chartered accountant with Arthur Andersen, the American accountancy company, which was good in a way because I had 3 years doing the physics side of it and 3 years doing a lot of the finance side. So although it wasn't planned that way, it was quite good background for what I'm doing now. In the intervening periods during my life, I was a partner in a firm of chartered accountants. I got bored with that. I ended up almost randomly setting up a chain of 90 retail units as well with my wife in the UK. We did ladies fashion. And I've always been a little bit entrepreneurial like that. So I basically chucked in the accountancy career and went into that. We did a franchise and we won franchise owner of the year in the UK. So that was like good. But how I got into this, back into energy and physics and all that kind of renewable energy side was this. We sold up our franchise business probably about 15 years ago. And I, like a lot of people, I do jogging every day. And we've got a river just about a mile or so from our house. And I go jogging down there every day. And this is probably about 12 or 13 years ago. And it's a tidal river. And I don't know if you have that many tides over here, but in the UK, we've got the second largest tidal range in the whole world, second behind Canada. I didn't know that at the time. I was just jogging along the river, Chad. And one day the tide's right up here, and next day it's right down there. And it's about 10 meters. And everyone at the time's talking about renewable energy. And I'm thinking, there's a lot of energy in the river there. Why is no one kind of harnessing it or anything like that? So after I started thinking about this and going along jogging every day, getting a bit annoyed about it, actually. So I thought, I'm going to do a bit of research on this. So this is how I got back into the renewable energy side of things. I did a bit of research on Google, which is great these days, obviously. I became aware that tidal energy was totally underdeveloped. It's a major source of potential renewable energy. Round my way, where I am just north of Liverpool in the UK, they were talking about having a lot of tidal energy from the River Mersey, from the River Severn. Anyway, I became aware of a small tidal energy group on the River Wye, about 20 miles just north of where I live. And I contacted them and I had a good chat on the phone with them and I went over to meet up with them. And they said, yeah, it'd be great to join our group. It's just like one of these amateurish groups. So trying to get something going in green energy. And the idea was to put a kind of barrage at the end of the river and just harness the energy when the tide goes up. And when the tide goes down in the sea, you allow the water to turn turbines and that creates electricity. And it's very standard. Anyway, at the end of this meeting, and there was a couple of professors there, they said, I was just going out the door and he said, and this is one of those life-changing events, Chad. He said, of course, there's always the potential to use the salt caverns. And I turned around and said, salt caverns? What are salt caverns? Anyway, so I went back in and he just explained to me how you've got all these salt caverns under the earth, man-made. So they've been basically when chloroalkali companies, like basically plastics companies like ICI in the past, needed salt underground, they solution mined the salt. So what happens, I'll just explain very quickly. Around the world, you've got layers of salt about 300 meters below the surface of the soil. So 300 meters down, probably the size of the Eiffel Tower. And then you've got the top layer of a salt field. And these are called salt fields. And that salt field can be another 300 to 400 meters thick, going down even further into the ground. And when the salt companies 100 years ago, like ICA, found out that all the salt was down there, they said, we need this salt because we need the chlorine to make the salt and also to make plastics, chloroalkalis. So what they do, Chad, is they don't dig it all up or do a big quarry. They put a pipe down 300 meters into the top of the salt layer, and they have another pipe coming up. So what they did, they flushed water down the first pipe, and the second pipe sucked up the brine. So it's 28% filled with brine. And that's how, so it was just like that. It was like just very simple way of solution mining. It's called the salt, out of the salt field. And this was being done 100 years ago. And what happens after 3 or 4 years is they get all the salt that they need, but it leaves what's called a salt cavern. And it's basically a great big kind of balloon size, a massive kind of balloon shaped cavity full of salt water, which again is about the height of the Eiffel Tower. So it's massive. Just to give you the background of where these things are, there's about 9,000 of these salt caverns around the world right now. So this is what I learned when I was talking to these guys on the River Wye about tidal energy. And the idea was, and this has been done already in Germany and Alabama, companies have come along and, just to backtrack slightly, 70 years ago, the fossil fuel industry decided to use these salt caverns because once the salt company's finished with them, they can't get any more salt in. They just leave all the brine water inside the salt cavern, put a top on it, a stopper on the top, and they just leave it there. What the fossil fuel industry just came up with about 70 years ago is that they could use these salt caverns to store methane gas and also to store oil and a whole variety of things like ethylene and ethane, a load of chemicals. And all they do is they get the pipes again, they flush out the brine with and nitrogen to clean them out, and then they pump methane gas under pressure at about 100 bars. And they've got a massive container, natural container under the ground, 300 meters down, full of methane gas, natural gas. And you might not know this, most people don't know this, but like 70% of the world's methane gas is stored in salt caverns and another thing called depleted gas fields. So the fossil fuel industry has been using these underground geological storages for the last 70 years. Then a couple of companies, like I said, one in Germany and one in Alabama, decided to put compressed air into the salt caverns. And what they basically did then, and these are still working today, they pump compressed air using off-peak energy into the salt cavern, and then it stays there at about 70 to 80 bars. So it's like a great big aerosol can under the ground. And when they need the electricity at night, about 5 to 7 o'clock at night, they release the compressed air through the other pipe. That turns a turbine around, and that produces electricity. For example, the one in Germany produced 300 megawatts of electricity for 2 hours at night every day to cope with the peak electricity demand. And then at night when no one needs the energy, they replenish the compressed air using off-peak energy. They just do a cycle like that every day. So that's like the research that I got to at the time. So at the time, I was looking at tidal, thought, wow, these are massive batteries under the ground. This is something that could back up countries. And obviously you can see these. So this was about 10 years ago, Chad. Obviously you can see these days, especially with the war in Ukraine, where you've got Europe in particular, if they're starved of electricity or starved of methane gas or oil during the winter time, it's a massive problem. So I was looking at this maybe 10 years ago and thinking, if there's a way of storing massive amounts of energy underground, then not only can you deal with the day-to-day peaks and troughs of the electricity grid like they do in Alabama and Germany, but you can also deal with what's called the seasonal problem, where a lot more energy is required in the wintertime than the summertime. So that's what I got into it. And at the time, I formed Storelectric, and that was like the idea at the time that you can have great big batteries under the ground. Maybe we were a little bit ahead of our time, but I got a few guys together. We also did some deals with Siemens, and PricewaterhouseCoopers were interested in helping us get finance, and Mitsubishi, some big companies. The next kind of turning point for me, Chad, with this was I met a university professor in 2015, and he said to me, Jeff, why don't you do hydrogen? Well, compressed air is good, but why don't you look at doing hydrogen? And I said, what's so good about hydrogen? And he said, hydrogen holds 150 times the energy capacity compared to compressed air per cubic meter of space in a salt cavern. So you get 150 times the energy. And I said, and I went up to that, I said, that's a complete game changer, because you could effectively half charge a third of a terawatt hour of energy stored in one salt cavern using hydrogen. And to put that into context, the entire UK as a country uses 1 terawatt hour of electricity a day. So one salt cavern full of hydrogen, if you stored the hydrogen underground like a big battery, and when you release the hydrogen, you burn it, and that turns a turbine around, creates electricity. Just 3 salt caverns would back up the entire UK's energy supply for an entire day. So this is like where we're at right now. So I wrote a patent at the time after meeting the professor. That was a bit of a game changer for me, because I shifted, thought compressed air is good. Let's look at hydrogen. So I wrote a patent, which I've been told is quite good. It's basically how to produce 100% green hydrogen using waste energy from industrial processes and from compressed. And it's been given in the UK and the EU. We're internationalizing it in America and Canada and China. But it was more than enough for us, Chad. It's like, this can't be some kind of thought process. It can't just be some kind of intellectual process. We've got to get some projects going. So we're looking at different sites where we can purchase the salt caverns and really get this technology going. And that's kind of like where we're at right now. So there's 9,000 of these salt caverns around the world. The idea is that a lot of these salt caverns are just, no one needs them. They're chloroalkali companies, but from their point of view, there's no more salt to be had out of them. So they're just like a liability for them. And the same thing goes with the oil and gas companies. So our kind of business model is to purchase these off them and basically repurpose them as great big batteries under the ground using green hydrogen. And the green hydrogen is produced using electrolysis from the excess wind from offshore wind farms and excess sunlight as well. So that's the basic idea. We've just got exclusivity on a site in Teesside in the north of England. And we need about 50 million quid to purchase the site. And we're actually talking with big companies like Mitsubishi and big investors right now, big ESG investors. And we're just trying to get one of these projects going. If we can prove that we can produce a 1 terawatt hour battery under the ground using green hydrogen, which is about 8,000 times bigger than the biggest Tesla lithium-ion battery around the world right now, and it would be absolutely massive. Like I say, a terawatt hour would back up the whole UK for an entire day. And there's lots of these sites around the world, and it would probably cost about $3 billion to get a site up and running, fully operational. But like I say, that this would be a great way of not only harnessing renewable energy so that it's not thrown away at night or it's not thrown away in the summer, but also a way of providing big energy security for countries. And I've got a meeting with NATO next week as well. They're really keen to look at this, because we need energy security. But if we can get energy security using green energy, green powered hydrogen, then that serves 2 purposes. It's like, it's not fossil fuels, but we've got a way of providing security for the European countries without having to rely on fossil fuels. So it's all about getting the projects going. And the last thing, John, you've probably got a few questions, but the other thing from my point of view is I'm a chartered accountant. This is all about the money. All the technology is doable here. It's like the electrolyzers, the salt caverns, the CCGTs that burn hydrogen 100%. The likes of Siemens and GE and Mitsubishi, they all produce these machines basically at massive scale. They're just looking for sites to showcase them as well. And my job right now is, and it's great talking to people like yourself, but my job is to talk to the big funds in Silicon Valley, the ESG funds. There's literally trillions of dollars out there that's looking for green projects like this. So I almost view myself as, it's quite interesting, like a middleman. I can find the project pipeline because these salt caverns are all over the place. the money is out there to actually finance these developments, and it's completely green. So it's almost like putting those two together at the moment, which is quite interesting using LinkedIn and things like that. And podcasts as well. Yeah, it's useful. So that's my kind of
Oh,
little
Jeff,
journey a little bit.
I never would have thought, I
No,
never would have known about salt caverns or thought about
well,
using them in this way. If our listeners wanted to learn more or contact you about investment or anything like that, how could they do so?
we've got a website called www.storelectric.com. So it's like Store Electric, all one word, a 1E in the middle. And there's a whole variety of information there. If anyone wants to invest, they're welcome to as well. It's like we've literally got 300 shareholders now. Chad, it's correct. It's crazy the amount of money that's going into this kind of thing. Well, like I say, we're really looking at getting the hundreds of millions, maybe the billions in investments. If there's, we always welcome money from the smaller investors. It's like that is brilliant, but it's the big money that's really going to make the change now for us. And if anyone
Thank
wants
you,
to get on
Jeff,
the
for coming
phone,
on the show. And
thank you, Chad. Thanks.
yeah. And thank you everybody for listening to another episode of Failing to Success. Make sure to smash that subscribe button. I'm your host, Chad Kalecki from Cosmic Web Design Development, and we'll see you next time.